Welcome to Unit 6B. Students are continually evaluated in one way or another. This practice provides the instructional system development team with the necessary feedback to judge whether the design and instruction is effective or not. The evaluation may be part of a formal testing program, or it may be quite informal. It may be as elaborate as a simulation of a real-life problem or situation, or as simple as questioning a single student. Additionally, instructors may evaluate just to see how students are progressing, or that they may need to give grades and make pass or fail decisions. As such, curriculum developers work with subject matter experts, instructors, for writing test items and testing materials. This is informative and relevant criteria for telling us what the student has learned. In the previous unit, we covered a process for writing student-centered objectives. In this unit, we will review the characteristics of test, evaluation, types of test, and test construction factors. Tests serve many purposes in the Air Force. Tests may have already been used when the target audience analysis was conducted, or pre-tests may have been developed as a prerequisite for attending a course. To ensure that tests adequately measure the objectives they support, the performance required in the test should match the performance required in the objective. A good way to develop tests that measure the objectives is to prepare them immediately after the objective is written. The primary purpose of testing is to assess the student's attainment of the behavior specified in the objectives. Tests also serve several secondary purposes, such as to identify problems or weaknesses in the instruction, indicate whether a class is performing up to standards on specific objectives, indicate instructor proficiency. Let's begin with discussing characteristics of tests. The instruments we use to measure achievement must be reliable, valid, objective, comprehensive, and capable of differentiating. Any given test or rating scale may possess each of the characteristics in varying degrees. However, few Air Force tests are completely valid or invalid, or completely reliable or unreliable. The goal is to design instruments with the highest level of the characteristics that give us the most useful evaluative information in a given setting. Let's review each characteristic further. A reliable measuring instrument is one that yields consistent results. For instance, if a tape measure provides identical measurements each time we use it to measure a certain length, we consider it a reliable measuring instrument. An unreliable instrument will not yield consistent results. For example, an altimeter that isn't set to the local barometric pressure, or cloth tapes affected by humidity, will not yield reliable measurements. Reliability means the same whether we apply the term to balances, thermometers, and altimeters, or educational tests and ratings. It refers only to the consistency of results obtained from a given instrument. It is important to note that no instrument is completely reliable, but some instruments are more reliable than others. We can sometimes determine the relative reliability of certain instruments. However, to aid our selection of testing media, there are four main factors to consider for determining test reliability: the test itself, including general and specific instructions and test conditions, the student taking the test, the scoring procedures, and the length of the test. Luckily, there are several things ISD teams can do to increase test reliability. 1. Provide the test administrator with complete written instructions on all phases of test administration, such as how to treat students, which student questions can be answered, what equipment and supplies that are needed and how they should be laid out, and what to do in various circumstances, student illness, equipment failure, etc. Second, test under the most consistent conditions possible. Third, make instructions to the student as clear and simple as possible. Fourth, make sure directions are as complete as possible without giving away the answer. Fifth, tell the student how the test will be scored. The student may be the source of unreliability due to issues such as stress, illness, or fatigue. In addition, lack of motivation may contribute to poor test scores, even if a student has mastered the objectives. Sixth, make the test longer. And last, give the measurement multiple times and compare results. Now, let's review validity. A measuring instrument is valid when it measures exactly what it was designed to measure. For example, mechanics who use a micrometer to measure the diameter of a bearing must be sure that the contacting surfaces of the bearing and the micrometer are free from grease and dirt. Otherwise, they will measure the coating in addition to the diameter of the bearing, and the measurement will be invalid. Although a measuring instrument may be highly reliable, it does not necessarily follow that it is valid. In other words, an instrument may simultaneously have a high reliability and a low validity. The instrument with maximum consistency, high reliability, may not measure what we intended it to measure. For example, merchants who use false scales may obtain reliable measurements but invalid results, at least from the customer's point of view. An educational test must exhibit the same characteristics of validity we expect of other measuring instruments. If we want an examination to measure the ability of students to apply a skill, it must measure the ability to manipulate appropriately, and not simply the ability to recall facts about the skill or merely explain the significance of the activity. For instance, if we design an examination to measure how well students understand the operation of a 4-cycle internal combustion engine, we should make sure we're not just measuring their ability to read the specification sheets. A test is valid when it requires the student to demonstrate the intellectual skill or motor skill performance stated in the objective. A test item is valid when it is performed under the conditions stated in the objective and is scored according to the standards stated in the objective. To ensure validity when developing tests, separate groups into 2 separate groups: critically important and less important. Include more than one item for the critically important and at least one item for the less important. In addition, you can create a pool of test items and rotate the test items used. Next is objectivity. This third characteristic of evaluation, objectivity, relates to the ability of a measurement device to be free from variations due to factors other than the behavior being measured, or the ability to grade with a relative absence of personal judgment or subjectivity. The bias of the rater or test scorer should not affect the score. To achieve objectivity, set precise standards and train the test administrator to apply them. Develop scoring procedures in which subject judgment or opinion of the score is not a factor. Tell the administrator exactly what should be observed while scoring. Clearly state standards of performance and define successful performance so that measurements do not depend on personal judgment. The fourth characteristic is comprehensiveness. Comprehensiveness means a measuring instrument must liberally sample the skills or knowledge being measured. For example, a boxing contender who only fights rookies or spars with one partner can never arrive at the conclusion that he's ready for the title fight because he doesn't have enough data to make that judgment. He hasn't been matched against different skill levels or styles of boxing to comprehensively measure his ability. Similarly, in classroom measurement, a test or rating must liberally sample the skills representative of the stated instructional objectives. An exam should not test just one area of the curriculum in depth at the expense of other areas that also need evaluation. In the ideal case, we would measure all course objectives. However, we usually have limited testing time available. Sometimes we write too many non-critical objectives rather than focusing on the critical ones. This would have the same effect of not sampling comprehensively. If we try to limit our objectives to those important enough to measure, we can construct an evaluation program that tests a much larger sample of our more important objectives. In any case, we must deliberately take comprehensive samples of as many objectives as possible. The final characteristic is differentiation. Differentiation is the ability of the test to distinguish between students who have mastered the knowledge or skill being tested and those who have not. We must construct measuring instruments that detect significant differences in ability. For example, suppose a machinist wishes to measure bearings that are slightly graduated in size. If we use a ruler to measure the diameter of the bearings, the differences among them may not be obvious. But if we take measurements with a micrometer, we may easily differentiate between the diameters of the first and second bearings, the second and third bearings, and so on up the scale. Similarly, we can design classroom tests to differentiate among our students. There are two methods of differentiation we need to recognize. The first is norm referenced differentiation, which is the comparison of items to each other. For example, let's go back to our machinist example. One goal the machinist might have in taking the measurements is to arrange the bearings from smallest to largest. When we want to show the relative difference in sizes of the bearings, our measurement is norm referenced. In a norm referenced evaluation program, a test or rating must measure small and sometimes relatively insignificant differences among the elements we're measuring. The second is criterion reference differentiation, which is the comparison of elements or items to a standard. Back to our machinist example. A more significant way our machinist might have used the measurement of the bearings is to compare each bearing to a standard to find out whether it meets established tolerances. The question then is, does each of the items being measured meet the tolerances? In the classroom, we should ask whether each student met the stated objective instead of how the student compared to the average. The former approach of testing distinguishes criterion reference testing from most traditional norm reference testing programs. The primary function of differentiation in criterion reference testing is to make a clear distinction between those students who have mastered an objective and those who have not. Rank ordering or letter grading is a secondary in importance. Now let's look at the types of tests used for Air Force training. How does an instructional designer decide what type of test to construct or what type of item to use? The best type of test is one which gives the decision maker the best information regarding the student's mastery of the objective. Different types of test items have advantages and disadvantages with regards to good test construction. These advantages and disadvantages have to be considered in terms of validity and reliability of the test. Most Air Force tests can be classified into two main groups: performance and predictive tests. A common question is, when should designers use performance tests and when should they use paper-pencil tests? These are the wrong categories for comparison. The comparisons should really be between performance test and predictive test. A performance test is one in which the student actually performs the skills required by the terminal objective. If the objective of the lesson is to recall information, then a test where the student has to recall the information by writing it on a piece of paper is a performance test. Many concept and rule using type performances are tested with paper and pencil tests. For instance, many problem-solving skills involving the use of scientific principles can be observed from written performance tests. Many types of tasks, especially equipment operation tasks, involve many different capabilities that have to be performed in an integrated manner. For example, the task of bleeding a hydraulic brake system involves recall of the procedure, information learning, physical performance of the steps, motor performance, recognition of the parts and tools, concepts, observation of the brake fluid conditions in the system, rule using, and attitudes, cleanliness and safety. In these type of tasks, performance cannot be measured by a pencil and paper test. A performance test would require a real or operational mock-up of a brake system. Because performance tests require the student to demonstrate mastery of the task previously learned, they are said to have content validity. Content validity is based on objective to test correlation. For a test to be considered as content valid, there must be a high objective to test correlation. This is true in both performance and predictive testing. Performance tests of integrated tasks are generally time-consuming because they often have to be conducted one-on-one with real equipment or simulators. If the actual behavior cannot be tested in a performance test because it is too costly, dangerous, or impractical, the next best option is to test the behaviors that enable performance of the desired skills, and from that information, make a prediction as to whether the student would be able to perform the task. For example, if a student could write the steps for bleeding a brake system, there is a better probability that the student could actually perform the task than someone who didn't know the steps. Tests that do not test the actual behavior, but test components or related behaviors are valid to the extent that they predict student performance on the actual task. Let's dive deeper into criterion reference tests. The lesson planning process concludes with the construction of test items and tests to measure learning. These test items are one method we use to gather evidence that students have learned what we intended them to learn. Test items are written prior to instruction because we will use these requirements to determine what needs to be taught. For example, if our test item is to identify the phases of the Air Force ISD model, determining this test item ahead of time gives us a pretty good idea of what needs to be covered in the lessons we will plan later. The support materials in the lesson should enable the student to perform the samples of behavior known as SOB. Hence, criterion reference test given after instruction is a post-test that measures students' attainment of the objective, measures the effectiveness of the instruction, is based solely on the requirements specified in the objectives, and used after instructional system is operational. In addition to using a criterion reference post-test to measure learning, curriculum developers working with SMEs can write a criterion referenced pre-test to measure performance on objectives to be taught during a unit of instruction and performance on entry behavior. The test is given to students before instruction begins to determine entry skills or knowledge and can be used to identify portions of the instruction the student can bypass. Generally, pre-tests are used after the instructional system is operational. First, analysis of objectives should identify what should be measured. To determine what to measure, list the tasks to be performed or objective statements to be covered by the test. One or more test items may be needed to adequately measure each objective. Tests should measure application of principles, knowledge of factual information, ability to perform tasks, and transfer of knowledge and skills to solve similar problems. Second, the level of testing, know, comprehend, etc., should correlate with the stated level of learning for that portion of the instruction being tested, no higher and no lower. Third, adequate coverage of the objective is the major effect in determining the length of test that is required. Longer tests are normally more reliable since they usually cover the material better. Fourth, selection and arrangement of test items. Select test items that cover the most essential and significant portions of the material. Test items selected should be clear, concise, and well written to minimize misunderstandings. Items of the same type should be grouped together in a test if possible. Individual test items should also be arranged in approximate order of difficulty, which allows a student to progress as far as they can without spending excessive time on difficult items at the first part of the test. Finally, when developing curriculum, we must consider the reasons for evaluating students. The purpose we have for using an evaluation instrument depends on the unique circumstances of the school, the instructor, and the students. Why are we testing? Do we test to improve instruction, pinpoint student deficiencies, identify specific degrees of skill achievement, or to predict success on a future job? Our answers to these questions will determine the procedures needed to reach these goals. If we are evaluating solely to assign grades, measuring instruments will be much simpler. In Air Force schools, however, our primary reason for evaluating is usually to determine whether students can perform a job represented by our stated objectives. Our task then is to ensure there is a strong correlation between the objective and the test required by the job. As such, an effective measuring instrument must be based on all 5 of the characteristics we've covered: reliability, validity, objectivity, comprehensiveness, and differentiation. In determining appropriate methods of measurement, we must select instruments that include the largest representation of these essential characteristics.